this week we're going to go and actually dig in a little bit deeper to the early history of astronomy, and then we're going to get into like the more Western history of astronomy. Particularly by the next class, we're going to start looking at the basic laws of planetary orbits and how those were developed. And your textbook does a pretty good job of laying those things out. I'm going to try to bring in some different sources as we go through. There's a lot of history that's been swept under the table. Science has this very strange ability to, well, I think it might have to do with the way that humans think, but science is written very monolithically. You know, this person came up with this person came up with this. It's almost never actually occurring like that. Usually people are coming up with the same ideas at the same time because the world is ready for those ideas, right? The culture has evolved to the point that it can accept new paradigms. The observations are coming in. The technology is available. There's new telescopes available. And so we'll try to dig into that. But for today, I want to basically set up a view of how astronomers really since antiquity and today look at the sky, some of the terminology that we use to talk about it, and then we'll go into a few of the different myths that were associated with the stars, because I think, and I don't have time to go through all of them, obviously, every single culture, every single region, every ethnicity has a different explanation. Your textbook focuses obviously on the Western one, because here we are in the West. And so I'm going to tear apart one of those pretty deeply and try to get to the bottom of it. And then there's we'll go into a Native American tradition for the same story and see how they differ and how they're similar, actually, which is really fascinating. All right, so before we get into that, though, let's just real quickly recap what we did last week. I want to make sure that everybody got the main points from that. Astronomy, physical explanations for what we see in the sky, right? And this has evolved from myth into talking about the actual physical objects. We talked a little bit about what an object is, which is starkly contrasted from an idea. Remember, all words, every thought that you have can be broken up into objects and ideas, which is a really fascinating concept, and we'll keep coming back to that. And it's not easy to say exactly what an object is, but I think that the closest thing we can get to it is it's something that has a surface that separates it from everything else. There's an inside and an outside to every object. Now, when you get into things like human beings, it's not totally clear if we're objects or what we are. We're more of an idea that lives through time, right? We have, of course, all of our atoms, but they're changing day to day. And so while my atoms will be different a few years from now, completely different, I'll still be here, and that's really fascinating. So anyways, astronomy is trying to make sense of the objects in the sky, how they relate to one another. And particularly, astronomy is really, we'll go back from that. Astronomy is really focused on laws, right? We're really, really obsessed with this idea that we can predict what's happening, and this has deep roots into history, because obviously, if you can tell what's going to happen tomorrow, not only are people going to feel comforted by that fact, but you're going to be able to plan things, you're going to be able to plan your harvest, you're going to maybe even be able to plan your fertility cycle, which is something I don't know if we talked about that too much last week, but of course, the moon, the cycle of the moon actually corresponds almost exactly in terms of length with the female menstruation cycle, which is pretty crazy if you think about it. Now today, we live under these bright lights and everything, so it doesn't really seem to have any relevance to us necessarily. But there's a lot of people who hypothesized that in the past, and there is some correlation too, that women's menstrual cycles align with the phases of the moon to some extent, especially in regions that don't have exposure to city lights and things like that. So these are really important things to keep track of, right? Especially if you're trying to plan a family. Remember, back before about 100 years ago, most of your children were going to die before they reached the age, like way more than most, right? Something crazy, like 9 out of 10 children were dying before they reached the age of, to be able to reproduce themselves. So being able to make lots of people was really important, and being able to plan that was really important. Making plans is really important. So astronomy started off being very much concerned with predictions, and today it still remains very much concerned with that. Now, the science side of astronomy, and I would say that predictive ability is a very technological thing. It's an engineering aspect, right? We want to be able to engineer our future. We want to be able to make it better. The science side of it is something that's kind of new, and that's actually that's actually narrowing down these mechanisms for how things happen, right? So, okay, we can say that the sun comes up over here. But in reality, when we start to drill down into the science of what's actually happening, the sun's not coming up, right? The Earth is actually rotating towards it. This is more of a scientific explanation, whereas being able to predict exactly where it comes up and when it comes up is more of an engineering aspect. And then, remember, this place is enormous. We kind of got cut off last time on our tour of the universe, but I hope that you got some concept of exactly how vast this place is. And it's only as vast as we can see right now, right? The edge of the observable universe is something like 14 billion light years away. So that means the things that we're seeing, especially with this new James Webb telescope, which is a far better telescope than the previous version, which was the Hubble, much bigger mirror, can capture much more light and focus it. It's seeing very, very far. And the things that it's seeing happened billions of years ago. So that's really something to consider. You know, if you, let's say you took a giant mirror, you know, somehow and plopped it 10 light years away from Earth, well, you could actually see 20 years into the past with that, which is just a really strange thing to think about. All right, so there's this time-distance relationship, and we talked about that a bit. Cool. So today, we're going to talk about the celestial sphere. That's our orientation schema by which we're able to pick out different things and measure them and the angles that are associated with that. We're going to go into the ancient astronomy, like I said. We're going to talk about the difference between astrology and astronomy, right? A number of you mentioned astrology as being kind of a fascination, you know, what's up with that? We're going to get into that. And then we'll maybe make it into the birth of modern astronomy. I don't know. We'll try. We're going to go as far as we can today. We'll pick it up next time. I think a really good place to stop would be right at the border of where humans started thinking about the round versus flat Earth. And obviously, flat Earth's making a comeback. I don't know if anybody noticed. Been out on the edges of the internet. There's, and this is fascinating too, right? Because you know, we have a very relativistic physics in our modern world right now, and it's all about the observer, right? And if your physics is all about the observer, it's not entirely unreasonable to say that everything is moving around you, right? That's not wrong necessarily, but it might not be the most mechanistic scientific explanation that we can come up with. So there it is. This is you. And when you look up at the sky and you look directly over your head, we call this your zenith, all right? And then as you look around to the edges, that's your horizon. You're probably familiar with the term horizon. Now, what's interesting, anybody who's taking the workshop, there was somebody pointed out to me, I'm sorry, I can't remember your name, maybe you can tell me, that there was a mistake in the quiz, actually, where the question was, what is the extent of your ability, your ability to see? How many degrees can you see? And obviously, in reality, we can only see 180 degrees, right? You've got 90 in each direction. Inside of the actual module for the workshop, you can sink down into the ground and expand that, and you can see a few more. I think it's 185 degrees, actually. So it was a trick question. I hope nobody got stumped on that. If you actually missed that question, send me an email. I'll give you credit for it. So there it is. This is called the celestial sphere. It's been used since antiquity in the Greek times, and we still use it today. And again, it's a very relativistic way of looking at the world because you're at the center of the universe in the way that we look at astronomy. And we're going to talk a bit about how that's shifted over the years. There's still cases in which we treat ourselves as the center and direct everything from around there. Astronomers have been moving past that to some extent. And we're going to talk about the different ways in which magnitude, the brightness of stars is treated, if it's treated with respect to us or with respect to some standard distance. Hopefully we'll get into that a little bit. Now what's really interesting is that the celestial sphere appears to rotate around the North Pole, South Pole, right, along this axis. So if you were sitting here in the northern hemisphere, everything seems to spin around a point towards the north, which is slightly above the horizon. In fact, it looks a bit like this if you could sit there all night. And I'm going to turn down the lights just a little bit. Looks a little bit like this if you're in the northern hemisphere. Now, can anybody imagine what it would look like if you were at the equator? Yeah, half, right? Half. And actually, if you're at the equator, you can see this on both sides of you. You see the northern celestial pole, and you also can see the southern, and they're both seated right there on the horizon. I think I got a picture of that. Yeah, there you go. This is one pole at the equator. If you turn around, you'll see the exact opposite. This is the stars spinning at night. So over the course of the evening, well, the stars aren't spinning, but we're going to treat them like they're spinning because, again, we're inside of this celestial sphere. So this is just a schematization from your textbook that shows the exact same thing. Now, what's really interesting is you guys have probably heard this concept of latitude before. And it seems a little bit, maybe you imagine that they just sort of arbitrarily define these units. But actually, the latitude is determined by the point of the pole as you look at it above the horizon. So for instance, here in Ashland, we're 42 degrees latitude. That means that the pole, the celestial North Pole, is 42 degrees above us, which is pretty cool. If you think about it, anywhere you go, you can actually figure out your latitude using this method if you can locate the pole star. And we'll talk about how to locate the pole star in just a minute. So, and you might also ask yourself, okay, I'm out here. How do I measure the degrees? I don't have a protractor or something necessary. And so there's some tricks we can use for that. All right, so celestial poles, celestial equators. Did we hit that? So your celestial equator is exactly where you might think that it would be. It's located at the horizon of where that pole axis would be. And there we are at 42.1946 degrees north here in Ashland. And the stars actually that are within that region too never set. So we're going to talk about the concept of the revolver stars later when we get to the Native American history. But you can imagine that when you're down at the equator, there's some stars you're not going to see at any given point in time. You have to kind of wait for them. Likewise, we're not going to see anything in the southern hemisphere from where we're at. Or at least we're not going to see anything below 42 degrees. Right. So to give you some idea of what kind of angles we're talking about, the moon is about half a degree. And a good way to think about that is if you hold up your pinky. Let me see if I got a picture of this. Here we go. If you hold up a pinky to the sky, it's about a degree, right? 3 fingers is about 5 degrees. Your fist is about 10. If you spread your fingers apart, you get a 15. And then if you spread your thumb and pinky, you get 25 degrees, which is about the size of the Big Dipper. We're going to talk about that. So this is a cool little reference that you can try out when you go outside. And you can actually try to measure your latitude this way if you travel. If any of you travel, down further south or travel north, especially around the holidays, give it a shot and see if you can guess your latitude. It's pretty cool. The sun, of course, is also wandering by about a degree as the seasons progress, which is kind of interesting to watch. I was reading this morning. It's quite interesting. The Navajo have some really particular etiquette about the sun. They treat it as if it's a very busy entity that has a lot of work to do, right? It's raising the crops, it's lighting the path. And so it's completely taboo to wake up during the sunrise. You have to wake up before the sun rises because you don't want to burden the sun with having to wake you up, which is quite interesting. And again, these are not like these aren't like primitive ideas so much. They're actually instructive because they're orienting the society towards some sort of higher value, which is something we're going to talk about in a little bit. But obviously, science can't talk about values. It can't talk about morality, right? But it's completely predicated on morality, which is interesting, right? And this is a huge crisis that we're going through today. We have unbelievable technology, right? We can split the atom. We can do terrible things with our science. And it's been a real struggle in modern times to figure out what we're going to do with that. and how we're going to regulate it, and if scientists should even be burdened with the idea of thinking about these sort of things. There's this very rational insistence on separating the objective side of science from what should be happening, which in some sense makes perfect sense because, like I said, science isn't even capable of analyzing those questions, right? I guess psychologists try to some extent, but probing something like morality experimentally is quite tricky. That doesn't mean that it's not built upon something that is moral, right? All of our ideas come from a place, and we'll see that. And this whole Western tradition that I keep going on about is fundamentally predicated on these moral assumptions. This is the reason, like I said last time, that you don't have to worry about your neighbor, jabbing you with scissors in the middle of this lecture. It's because we all sort of know how to behave. And it's not totally clear why you know how to behave. Obviously, your parents taught you, not to do that. But it wouldn't take you very long, even without parents, to figure out that you can't behave that way. And there's a lot of ways that are built into our psychology. And they're built into our science, too, which is quite fascinating. And I think we'll see that crop up throughout the lecture, throughout the stories that we're going to get into. So this is another word we need to become familiar with. It's called the ecliptic. And what is that? Well, that's essentially this plane upon which all of the important planets, let's say all of the planets and all of the bodies that we'll be concerned about immediately reside. It's about 18 degrees. And you see these very familiar constellations within this 18 degrees. And obviously, they're important constellations because they allow us to tell where those planets are that we're watching throughout the seasons of the year. And they're moving, of course, right? So at different times, you're going to have the different planets setting and rising in the present in different constellations. This is called the ecliptic. And you can think about it as a platform in which all of these bodies are moving. And we'll get into this more later, but you've probably asked yourself why they're all in a disk like that. And it's a complicated answer that we'll explore when we talk about how the sun is influencing bodies, not just gravitationally, right, but also through electromagnetism, and also through its interactions with other stars, which is something that we're really just beginning to understand, right? This is, I think, at the heart of the dark matter crisis in cosmology and in astrophysics right now, which we touched on just a little bit at the end of last class, right? It's not entirely clear why the stars are moving through the galaxy the way they are. In fact, it's completely unclear. They don't seem to obey gravitational dynamics as they should. But we're just beginning to think about the fact that, hey, these stars, like our solar system, extends outwards almost halfway to the next star, right? And we can assume probably that star's solar system extends outward to the same point. So there's probably a lot of friction between these different solar systems, right? And friction's a really important concept in physics that gets not as much attention as it deserves. Because how do you do anything in the world? Like, how do you move, right? You require friction. You have to grind into things. So friction is the enmeshment of surfaces, these objects gearing together, right? And so there's people talking about how this might actually play an important role, right? If this dark matter thing fails to actually prove out, if we can't detect it, we're going to have to look for other explanations. And there might be some interesting dynamics there in terms of the solar systems grabbing onto one another in a non-gravitational mechanism through friction, which is something to really think about. All right, so we talked a little bit about the seasons last time. I don't have too much more to add to that. But, of course, the Earth is slightly, and many of the planets are slightly offset. In our case, we're offset by 23.5 degrees. So as the Earth moves around the solar system, as it orbits the sun once a year, you're going to have more or less of each hemisphere exposed to sunlight. And this is where we get the seasons from. A lot of people have the misconception that the seasons come from the Earth actually tilting, changing its tilt, or that it comes from your proximity to the sun. That's the one I've heard a lot. Oh, well, it's summer because we're closest to the sun. That's actually not the reason. It has to do with the tilting axis as it moves around the sun, like this. So let's keep that in mind. Now, the ancients called, at least the ancient Greeks, the ancients in our Western tradition, which actually extends all the way back to Sumeria, they called the planets wandering stars. Okay, this is actually completely appropriate because if you go outside and you look up, did anybody see Jupiter last night by any chance? Yeah. Oh, cool. Yeah, me too. I had my telescope out. I was stoked. You could see all the little moons and everything. If you look up, they look like stars, right? It's not an unreasonable proposition. But what the ancients noticed was that some of those stars didn't stay in place like the rest of the stars. And they called these the wandering stars. They turned out to be what we call planets. And this wandering pattern was so important that we ended up inheriting the days of the week, for instance, from these names, right? Especially in antiquity. So what's really fascinating is that today, Monday, Tuesday, Wednesday, these are a mishmash of the ancients' naming of the planets, which was based, or naming of the days of the week, which was entirely based on the planets. And then we mashed it up with a bunch of European folklore and mythology. So, Sunday, obviously, for the sun. Monday, for the moon. Tuesday, this is a weird one, right? How many of you have ever heard of the god Tu? Yeah, all right. Yeah, okay, somebody. I hadn't heard of it, but this is a Norse god. Wednesday is for Woden, which is a Norse god, a supreme Norse deity. Does anybody speak Spanish? Couple? Yeah, I used to speak it better than I do now. Wednesday was, in Spanish, is miércoles, and this comes from Mercury. Thursday is actually Thor's day, which is quite funny. But if you look at it in a Latin language, like Spanish, it's jueves, which is a Latin for Jupiter, actually. It's a Latin derivative of Jupiter. And then Friday, this is Freya's day, who's another, the Norse god of war and beauty and love, which is an interesting concept that love and war should go together so nicely. But of course they do. I'm sure you're all having your first, well, maybe not your first, but you're exploring the romantic side of life. And but of course in Latin, Friday is Viernes, this is Venus. And then that brings us back around to Saturday, which we keep, it's still Saturn. So that's quite interesting. So we have this mishmash in the West. And I think this is really worth considering for a second. When the Romans came to Europe, they absolutely obliterated the cultures that were there before them. And we talk a lot in America about how we obliterated the native traditions that were here, especially the Spanish when they came through Mesoamerica. They burned all of the manuscripts with the exception of a few, which we thankfully have today. But the Romans did it even worse. They literally wiped these civilizations off the face of the earth. So it's kind of astounding that we have any little shred of that culture which remains. And it's in our days of the week, and there's other places you can find it too. The Celts, the Picts, the Carthaginians, they took entire civilizations off the map and destroyed all of their history. I mean, Carthage I don't know how many people know about Carthage. Yeah, okay, nice. Carthage was a civilization to rival Rome. I mean, the Carthaginian army drove completely around Spain through the Alps with like elephants and horses through the Alps and sacked Rome, actually. And sacking Rome doesn't work out for you, it turns out, because the Roman general's son actually came around later and burned Carthage to the ground, which was just across the Mediterranean. And this, unfortunately, is how our civilization has gone in the past. It's a tradition of a lot of destruction, but we can try to reintegrate some of those ideas now that we know. So, what else can we say about this? Yep. All right, so today there's 88 constellations that are extremely important. And again, as we get in, we're going to start into some of these stories. These are not archaic superstitions. They're absolutely overflowing with meaning. Each one of these stories is there for a very important reason. And then when we look across cultures, we start to see that people come up with similar ideas. And that's really fascinating, right? There's there's a very similar creation myth in almost every single culture. And that's not because they were all talking to one another. It's because there's actual events in the course of human life that are there from the beginning. They're built inside of you. And that's really stunning to think about it, that people could derive the same meaningful stories without ever communicating with one another, because they're built in. I mean, most of the things that you do, you don't have to think about. You know, you don't realize that totally, but again, you know what to do all the time, and you don't have to think about it. There's things that are hardwired into you. You can say it's genetic. Certainly it is to some extent, but most of the things you're doing, you're not thinking about. Most of the ways you're behaving, you're not thinking about. And all the cultures seem to come up with similar ideas about that. So here's one. This is Orion. And Orion's been getting a fair amount of attention in the news lately. And I'll just take a quick aside to talk about this star up here, this big yellowish one. And you can see this one if you go out, and I highly recommend that you do. This is a very bizarre star. It was actually named by the Islamic scholars, the Arabic scholars, who actually were some of the most dedicated note takers and gave us some of the best star catalogs. And this was around first millennium AD, a little bit earlier. And they named this star Betelgeuse, which actually is an English version of the word that says the hand of Al-Jauza, which is the Islamic name for Orion. So this is a freaking huge star. Actually, if it was here in the solar system, it would extend all the way beyond the asteroid belt, right? It would eat up all of the rocky planets, including us, and Mars, right? It would reach all the way out there to the asteroid belt. And the asteroid belt's quite interesting too. We'll talk about that later. What's the deal with the asteroid belt? Is it a smashed up planet? Is it captured from the Oort cloud? We'll talk about that. So starting in October of 2019, Betelgeuse began to dim, all right? It dropped its magnitude by a factor of about 3, so it got 3 times dimmer, which is very strange. And all of the astronomers started freaking out a little bit. People were like thinking this thing was going to go supernova. It's of course potentially going to be impacting Earth if that happens. There's a lot of evidence that supernovas have given us great pause for concern in the past. And of course, the interesting thing about supernovas, and just to be clear, a supernova is one way that a star can die. They can die really boringly. They can just sort of putter out. But sometimes they explode. And it turns out to be really important because the prevailing theory today is that when supernovas do occur, they give off a lot of the big, heavy elements that we need and that have been instrumental on Earth. And so people were very concerned about this. And actually, it bounced back. And I guess this is a good point to talk about magnitude, especially this is how we talk about the brightness of stars. So what is magnitude? It's actually a very nonlinear scale. So something that has a magnitude of, say, something that has a magnitude of 1 is not twice as bright as something that has a magnitude of 2. So the way that this works is that you're actually taking the square root, the fifth root, sorry, not the square root, the fifth root to get a brightness ratio. And so this means that something that it has a magnitude of 1 is about, let's put it this way. A star that has a magnitude of 2 is actually 2.5 times brighter than a star that has a magnitude of 3, and so on and so forth. So something that has a star that's a magnitude of 4 is actually 100 times brighter than one that has a magnitude of 7. And the reason that they did this was because the ancient astronomer Ptolemy assigned randomly, this is the brightest star, and he gave it one value, and this is another class of stars, and he gave them another value, and it was sort of arbitrary. But when the modern astronomers came along and they actually had the means to measure the true brightness of it, right, using different, more advanced meters, they wanted it to line up with the ancient star catalogs. And so they hammered the equations together until they were able to actually come up with a scale that very closely matched what the ancients were using. Because they weren't wrong. Those stars really were brighter than the lower magnitudes, right? Okay. So, or than the higher magnitudes. So the scale is reverse logarithmic, and the brighter an object is, the lower the magnitude number. This will become important as we start looking at the different star systems later. So something that's extremely bright actually can have a negative magnitude. So Venus, for instance, has a negative magnitude of minus 4.2. The sun is actually a minus 26. And then something like, say, our closest companion, or let's say Sirius, which is a nearby star, is around minus 1.46. So let's keep that in mind as we look at the stars and we talk about their brightness. This is not an absolute scale. It's logarithmic. All right, so Betelgeuse. What happened with Betelgeuse? Why was it dimming? Why did it stop dimming? Well, the conventional theory is that this star is on its way out, and as it dies, it's coughing out pieces of itself. And what happens is when they fly out into interstellar space, they cool and they form a dust which blankets it, and this is why we were unable to see it as brightly as before for a little while. It's just a theory. People don't really know, and there was all sorts of really fantastical theories going around at the time. You know, maybe it was spaceships from another civilization, right? Maybe they had set up solar panels all around their sun, or they were trying to actually harvest all of the energy because, you know, we get some very tiny percentage of the amount of power that's available to us from the sun. So there's already people scheming on how we can get more of that, which is a really interesting concept. And it actually might play into something people were talking about, that you guys were talking about in your responses, which is there other life out there? And why don't we see it? And there's everything from the cynical perspective to the very optimistic perspective. But I think it's worth keeping in mind that if there was an advanced civilization, it might not want to be seen, right? And so it also might be, as I just said, it might be actually blocking out its own sun because it wants to harness all of that energy. So we might not see the other civilizations because they don't want us to. Maybe once we start behaving a little bit better, they'll want to hang out. Okay, cool. So I want to talk for a few minutes about about a constellation, the Bears, the Ursas, and in particular about a little portion of the Ursas. So you guys have probably seen this painting before. You might not have noticed that the Big Dipper is in this painting. I actually never noticed that before. I've seen this painting in person. I never even thought about that, actually. But there it is. This is a really important feature in the sky. It is not a constellation, though. It's what is called an asterism. Okay, an asterism is a portion of a constellation. And again, this is within the Ursa constellations. There's an Ursa Major and an Ursa Minor. This means big bear, little bear. And we'll talk about this bear idea because it pops up in different cultures, which is really interesting. So why do we care about this one? Well, it allows us to find the pole star, all right? And of course, the pole star is really important for navigation because we can learn our latitude from it. So the Big Dipper, which is somewhat easier to see, points nicely at the North Star, which is in the Little Dipper. This is really important. If you can identify one piece of a constellation when you're out there tonight or whenever you're out there next, this is the one to look for. This is the one to know. You never know. It might save your life if you're lost in the woods, right? So there they are, the bears. And this is the bears in the Western tradition as we know it. And again, as we go through this, I want you to really stretch your imagination to try to, and I'll give you my interpretation, but I want you to really stretch your imagination as we go through this story to imagine the significance of it and what it could be saying about life and what these people were trying to teach one another and teach their children and what they were trying to immortalize in the stars when they pasted their deities and their mythological creatures up in the sky. Okay, in the West, We call this Ursa Major. Let's take a look at it one more time. This is Ursa Major. Does it look like a bear? I don't know. Not really, maybe? That's not the point, right? The point is that the bear was an essential part of a story which they were able to immortalize and put in the sky because, again, they didn't have PowerPoint, they didn't have the internet, they didn't have TV, they didn't have movies, right? If you wanted to actually go out, right, if I was going to give this lecture 2,000 years ago, we would just be sitting there under the stars and I'd have to point at them and tell you what's happening and come up with stories. And honestly, remember, the astronomers of antiquity were not appreciably different from the priest class, which is really interesting. And many of you in your responses had metaphysical questions, right? The stars awaken something metaphysical in people, right? They're beyond our knowing, right? They're in that realm of chaos. We don't understand what's happening up there. And certainly people 2,000 years ago understood even less. And to be honest, just because we understand that stars are these burning balls of material and so forth, doesn't really make us that much more enlightened than the people who were looking at them 2,000 years ago and said, no, these are actually representative of this feature, this archetypical feature of living on Earth, right? And so let's talk about that. So these are the players. And what's really fascinating is that for the bear story, the tradition was actually inherited by the Romans. And so we have two names for every single character except for Callisto. And in the Greek tradition, it was Zeus, who's the father deity. Every single culture has a father deity, father sky, right? In the Native American tradition as well. And his wife was Hera, and who is, of course, the mother deity. And then there was this beautiful nymph who dwelled on Earth amongst the forest creatures. Callisto was she was a servant, let's say, she was part of the cult of this supreme earth deity who was named Artemis. And very dutiful and devoted to Artemis. And then we'll talk about Arcas in just a second, but this turns out to be, I have Diana's son. This is actually Callisto's son. I'm sorry about that, my mistake. Okay, this is interesting. Okay, so what's that? No. Yes, exactly. So she's virgin, right? And this is very important in the Roman tradition. The Romans actually kept a stable of virgins in their temples, right? And it was a very good life if you were selected to be one of these virginal vestals, actually. They had the finest food, they had great housing. In fact, if you could get your daughter to be elected into this temple, it was very wonderful for your family. You would be given, they would only serve, I think, for 7 years, and then they would retire, and they could go back to their normal life, and they didn't have to be virgins after that. But if the Vestal virgins in any way violated their code, they met a terrible death, right? It was not like you get to say you're sorry, right? If for some reason they ran off with one of the village boys or something like that, they wouldn't just kill them either. They would actually seal them up in a dungeon and forget about them. They would just bury them alive. Yeah, that's a rough way to go. Okay, so anyways, I apologize for this typo, but I'll tell you the story. So there's a couple versions of this story. It starts off sort of like this. The father deity becomes infatuated with this nymph, right? This forest creature. And he knows he can't get close to her because she's obviously devoted to Artemis. She's a sworn virgin, but he doesn't care. He's going to find a way to do it anyways. So he disguises himself as Artemis. And in the Roman tradition, this is Diana. And he goes down and he gets very close to her. And he ends up essentially forcing himself upon her, which is very tersely mentioned in all of the texts. It's a sort of horribly violent moment. And before she can stop this. And before she realizes what's happening, he impregnates her. And later on, Artemis discovers that Callisto is pregnant and flips out and actually turns, she casts her out of her community and she turns her into a bear, okay? Which is very bad news because actually Artemis is in some sense in charge of not only the wild animals, but also she is the deity that they would pray to for hunting, right? She guides the hunts. So this is like a particularly vicious fate. It's a particularly vicious punishment because she has turned Callisto into the prey. And then, depending on which version of the story you listen to, she gives birth to a son. The son is Arcas. And he becomes actually the king hunter, which is also terribly ironic because his mother's a bear. And, bears have any of you ever seen a bear on accident? Yeah, okay. Me too, right? It's quite a terrifying thing to have happen to you. And of course, the bear in this day, in this olden day, and I think to some extent today, it's a very, it's a prime target for hunters, right? It's a very difficult thing to kill a bear, even today. And it certainly was difficult when all you had was arrows and swords, right? Honestly, I think it's very hard to kill a bear today without some very high-powered rifle, right? I've heard stories of people who are shooting them with handguns and stuff, and the bear just doesn't care. So the bear is like a archetypical target, it's archetypical prey for humans. It's very difficult, but it's highly regarded if you can catch a bear. So this is significant. And so we ask ourselves, what does this story mean? Because what's really interesting is that 1,000 years later, the Romans picked up the same story and they swapped the names around, but they kept the story more or less. And I think that there's a number of interpretations you can make from this. I would love to hear some of your ideas too. So please, go away this week, think about this story, think about what it could have meant to the people. Tell me about it next week. Tell me about it after class. I want to hear your ideas because I absolutely racked my brain all day yesterday trying to think of what this story could possibly mean. And I think there's something really, really fundamental. There's many stories embedded in this. There's obviously the admonishment of the young female, the vulnerable female, Callisto, who's perhaps vulnerable to deceit, right? This is something that young ladies have to, and young men to some extent, obviously. It's a very different set of dangers for young men than it is for young women. But this idea of being deceived by someone that you're perhaps courting romantically is built into this. But there's also this idea that the father deity, the supreme deity of the sky, wants to know the earth, right? And I think this is largely where humans find themselves as well. We want to know everything about the world. But sometimes by doing that, we can unleash a great deal of chaos as well, right? We learn to split the atom, which is great. Maybe we can have nuclear power, which is the cleanest, safest power source by far, right? It's an amazing power source, but we can also destroy the entire planet if we want to, very easily and very quickly. And so there's some grain of this idea, and this is also overlapping to some extent with the Christian tradition of Adam and Eve, where there's this knowledge that's obtained, right? He goes in and he knows the earth. He knows, and what does it mean, like biblically, to know someone, right? It's to actually be intimate with them. And in this case, he goes and he knows this forest, but he creates a great disaster by doing this. And I think that there's some inherent truth there. Now, what's really interesting is that when the Romans adopted this story, they changed it just a little bit. And this is also quite fascinating because, they didn't change it. They didn't necessarily flatter the female characters when the Romans changed it. And, we've the Western tradition has been obviously very patriarchal. And I don't mean this in terms of like, this is some evil thing necessarily, but it is definitely, the Romans did not have much of a place for women in their politics. But what's really interesting is that the Greeks inherited a tradition that did. So does anyone know who the Minoans are? The Minoans were amazing, but no one knows anything about them because, of course, the Romans are great at erasing history. These are the Minoan matriarchs, okay? The Minoan culture was matriarchal. The women ran everything. They were in charge. They were the landowners, and so on and so forth. And so what did the Romans do when they inherited this story, which almost certainly came from the Minoans? They twisted it just a little bit. The difference in the Roman story, in addition to obviously the names all changing, is that instead of the earth goddess, in their case, Diana, banishing the Callisto to become a bear, it was actually the jealous wife of Jupiter. What's that? Yes. So the Hera of this tradition was spiteful and jealous, and there was actually, the more we go, and we'll go into more Roman mythology throughout this course, there's this very interesting shift towards treating the female characters as having this edge of danger and spite and jealousy. And I think it's significant. I think that they did this because they were, in some sense, inheriting the tradition of the Minoans, and they weren't super keen on having this happen again for whatever reason. So there's a war, boys versus girls, it seems like, in antiquity. And the boys won out in the Roman society. They were way better dressers. Actually, I absolutely, I want you to all go and look at the Minoan dress at some point. Something very interesting, completely off topic, but the Minoan women did not cover their chests in public. It was actually it was a sign of their power, actually, sort of like the way that in some cultures men grow these huge beards, right? The women were bare-chested and they wear these elaborate garments. You can see to some extent their chests are completely out. And this is just fascinating when you think about the implications for a society that's dominated by the women as opposed to the men, where the men are actually subject, like their power, like obviously men are dangerous, right? And so we have ways of controlling the danger of men today. And it was somehow different back then. And unfortunately, we don't know enough about it. But I just love the Minoan story in general. We'll probably come back to it as we go. So that's my take on it. I'd like to hear yours. It's something we have to really think about. Each one of these stories, again, these were not just superstitious idiots. They were telling stories that were really important to teach the children, to teach each other how to behave, and actually to try to make sense of how we already behave. Why do we behave the way that we behave, right? Like I said, you're doing all of these things all the time, and you don't even realize you're doing them. But why have we adopted these behaviors? I think that's largely what people would sit around talking about when they're developing these myths. Some of the best movies that we have today, obviously, when you watch a really good movie, you come away with something that you can apply to your own life. You're like, wow, that guy got really messed up by acting this way. Or this person, was betrayed in this interesting way. Maybe I should watch out for that. And I think that that's the purpose of these myths. And that's why we've memorialized them in these stars to this day. And as you'll see, we're not getting rid of the constellations anytime soon. They're actually how we reference what we're talking about. If I want to say to you, all right, let's go check out this star, the first thing I'm going to say is the star in the constellation blank, right? They're not going anywhere. These are important stories that will continue to be. And maybe they need an update too, right? Maybe the Western tradition will be updated and we'll give a new story that will tie along with this. Maybe there's already movies that coincide very nicely with the Callisto story. So let's take a look at the Native American tradition, which is quite interesting. So 3 tribes that I could find actually also use a bear in their story. That is the Iroquois, the Lakota, and the Algonquin also use a bear. And I'm not going to have time to go into each one of their stories today, but they're not so dissimilar, right? The bear is a formidable foe, and so having control of it, having it appear in the sky, something that you can actually understand and keep track of. You can keep track of the predator. This is a good feeling, right? And you can placate it, right? You can speak to it. You can ask it for protection. But the one that I want to talk about, which is the one that this book that I've been going through mostly features, is the Navajo tradition, right? So the Navajo don't treat it as a bear, actually. They treat this asterism, the dippers, as a pair of entities. There's a male and a female entity. And this is something that's really cool about the Navajo tradition, and honestly, several other Native American traditions too, is that we didn't have to, they don't necessarily have to have this boys versus girls war that the Romans and the Greeks and the Minoans were having, right? There's this deep sense of harmony that's absolutely critical to everything functioning as it should. There's a balance that has to be occurring. The women are not less or more powerful than the men in these societies, and their myths reflect that. So I'm going to read you just a little bit about the male and female revolvers, which is Ursa Major and Ursa Minor. Again, I totally recommend this book. It's called Native Science. If you want to spend a couple bucks, you don't have to, but it's very good. And it's actually written by a Native American astronomer. So here we go. In Western astronomical view, the Big Dipper is complemented by Little Dipper, as we talked about. The Navajo don't see dippers, but rather male and female revolvers. The male revolver's body consists of 7 stars, and 2 stars represent the warrior's feathers. The female revolver's body also consists of 7 stars, balanced. The male and female revolvers are viewed as a paired constellation rather than separate. The male revolver lies next to the fire between him and the female revolver. And this fire is that pole star, right? The central fire is known in our culture as Polaris, or the North Star. 4 stars surrounding the fire are guarded by the revolvers, extend to the 4 cardinal directions. To the Navajo, the fire is sacred and represents home, and a strong fire means a strong home life. The revolver pair serves as guides to other constellations as well as to the people of Earth. So they really believed that these things were actually the spokes, right? This is the center of the wheel that's holding everything together. It's not an unreasonable idea. And to be honest with you, the more that we understand, we'll talk about Ernst Mach later and the idea that things are connected to one another. It's not entirely unclear that that's not true, actually, to some extent, and that all of these things, whether you want to call it gravitationally, friction, whatever you want to say, it does seem like things are connected to one another. Actually, you can test this right now. Well, let's not all do it, but if you spin your arms around, if I spin my body around and let my arms loose, my arms fly out to the side. And this actually seems kind of trivial, like we all know this happens. But why does it happen? It's very strange, actually. It's almost as if my arms are being held in place by something. What are they being held in place by? And there's this gentleman named Mach, and I'm sure you've heard about the speeds being named after this guy. And his proposition was that you are actually attached to everything around you, and that when you spin, you're being held in place. And this is kind of the root of inertia. Let's keep going. We'll get back to that guy. The cycles of the revolvers measure the seasons, and they appear in the sky at different locations depending on the season. So the revolvers rotate clockwise around the central fire, which is the pole star, while the Earth rotates counterclockwise. The revolvers help the people identify the seasons in the time of night. For instance, when dawn approaches, the male revolver is standing. People are expected to rise at dawn, face the east, make their offerings, and begin their daily activities. In the protection way ceremonies, the male revolver is key to helping restore balance and harmony to the lives of the family. The disharmonious elements that have infiltrated the family are cast away past the revolvers in the fire. The revolvers are there to protect the family from the dangers that may try to return to them. So this is a really modern way of looking at things. Actually, if you go way past the Roman traditions, the new Western tradition, or at least let's say maybe not so popular as it used to be, the Christian ideas of forgiveness begin to show up in the Native American traditions, right? You're able to cast away. Every morning you get a new slate. As these things turn, you can actually start anew. And this is really important because it seems like Rome would have been a terribly difficult and heavy place to live, right? Especially if you're not one of the chosen few. So this is what they're talking about. In each of the seasons, at the same time of night, you're going to have the dipper in a different place, right? This is the revolver concept. And throughout the night, it revolves as well. All right, what about other traditions? Don't really have time to go through each one of them in detail, but let's mention a few. So in India, these are called the Saptarishi. Anybody with an Indian background who's aware of this story better than me? No. All right. So these 7 sages each have their own tradition of stories and feats. They're all heroes in the Vedic tradition. And so there's not like a consolidated story that I could find that relates to the actual Dipper. But needless to say, each one of the 7 stars represents one of the 7 stages. And you can think about each one of these, I think, as something like a prophet in the Western tradition. They're each replete with their own heroic journeys and efforts. But let's say we go to China and Japan. We see the concept of the pole star being related with this god Myokin, who was a god of war. If we go to Korea, we see it being associated with an interesting story, which also might be something you want to think about. I haven't come up with a great interpretation for this, but essentially, there's a widow. She's raising these sons by herself, and she basically starts an affair with her husband's died. She has these 7 sons. The sons are great. They're revered in this tradition. She's going to visit her boyfriend, and she has to cross this very difficult stream. And so what her sons would do is they would go and crouch in the stream and act as stones so she could step across it. And in some tradition, the story stops there, and she prays to the Creator God that perhaps they could be made immortal, and so they end up in the stars. Now, there's another interesting tradition of this, and you can see culture starting to bleed into it, where the consort, her boyfriend, becomes very jealous of her devotion to these sons. And so he's trying to get rid of them, and so he pretends that he's sick. And some fortune teller claims that the only way he's going to be healed is if he takes the livers from those sons and makes a potion out of them. And so, right as this is about to happen, the mother goes out and encounters some beast, not sure what beast, but probably a bear. And the beast gives them livers, and this satisfies the potions, and the story proceeds as usual. So, very different, but again, you see this tension between perhaps the male and the female energies. And you see perhaps different cultural associations as different groups, different political powers took power over that culture, right? They're going to shape the myths a little bit differently. And that's really fascinating to watch these things change over time. I think we can learn a lot about where we're at right now. I'm going to talk a bit about where we're at right now with our myths at the end of this. But let's keep going. So if you are Finnish, you're going to see a salmon weir. What's a salmon weir? Well, it's like this little trap that they catch salmon in, right? I think all of these traditions, how about in Burma, you see a lobster, right? And these make sense because these are the central fascinations of those cultures. They're all gathered around these activities, and their stories are going to relate to that. And so I encourage you to go and read the details of these stories. We can't get into all of them right this second. I want to pivot a little bit and talk about astronomy versus astrology, because astrology is a very popular and fun thing to check out. So I don't even know if there really are newspapers anymore. When I was a kid, you go into the newspaper, and every week in every newspaper there's an astrology column. And it'll tell you your fortune, right? So does anybody know how you know your sign? You've talked a lot. I'm going to ask somebody else. And what does it tell you, though? Something about the sun rising in some sign, right? Yeah? Yes, exactly. So as you look back, the sun is going to rise in a particular constellation, right? Now, what's really funny, though, okay, hold on. So there's some problems, obviously, with astrology. It is quite fun, and honestly, these columns are certainly, I do encourage you to read them. They obviously give you some advice. They're usually useful advice, like be careful, something like that, or go out and meet people. They're all very generalized. And often one of the first reasons that people began to doubt astrology is that they would be different predictions in different newspapers, right? And they would sometimes conflict with one another. Go out tonight and don't go out tonight. People are like, what's going on? This is strange. But what's really interesting is that, does anybody know their sign? No, you don't. You know your sign from 2,000 years ago, right? So what's really fascinating is that the pole star, our pole star Polaris, will not be the pole star in 26,000 years. Because there's a little, like I told you, the Earth is at a bit of a tilt, 23.5 degrees, as it moves around. But that tilt is actually wobbling a little bit like this. And so the Earth is actually going like this as it moves around. And it takes thousands of years for this to happen. However, it has moved enough since the invention of this astrology system that your sign is no longer your sign. So I thought I was an Aries my entire life. But it turns out I'm actually a Pisces. So what you need to think about is actually where you are in terms of the precession today. So you're actually one step ahead of what you probably think you are. Did anybody know that already? Okay, fair enough. Good on you. So what else, though? What's the main difference here with why is astrology not considered a science? Let's back it up. What is the mechanism? Let's say if we were going to make astrology a science, what would the mechanism be by which the stars would influence your life on Earth? Anybody? How would they do it? Yeah? That's how you would test it, yes. But how would they affect you? How could they affect you? Yeah. Yeah. Right. Right. Exactly. So this is what was traditionally argued to be the case. The problem with that is that gravity is quite strong when you have two bodies that are more or less close to one another, for instance, me and the Earth right now. But gravity falls off very, very quickly, okay? So what's the biggest body, like the biggest sign, let's say, the biggest astronomical body that might have an effect on you? And I say this with some reservation because, like I said, with Mach's principle, it does appear that we are connected to our surroundings. And so I say this with some reservations. But let's just look at a special case. Jupiter is an enormous planet, right? It actually contains it actually moves the center of the solar system slightly off from the sun. And Jupiter's radius is about 43,000 kilometers. It's about 588 billion kilometers away, which is about 13,000 or so times the distance, its radius. So the effect of gravity, since gravity works with an inverse relationship to the square of distance, the effect of gravity, it would be 1 over 13,000 squared, which actually results in 5.4 times 10 to the negative 9th times Jupiter's gravity affecting you. So my gravity standing next to you would be a lot more than that, right? And so the argument is often given that there's no possible way that these gravitational interactions can have any effect on you because gravity is so weak at a distance. However, all of the stars added up, all of them, and we don't even know how many there are, right? We can make some estimates, but remember, the universe, as we speak about it in astronomy, just means how far we can see. For, God knows how big it is. It could be 3, 4, 5, 6, 7, hundreds, thousands of times as big as we think it is, right? That's a lot of stars, right? And so I keep the reservation that, maybe there's something to that. It's not clear that it's playing out in every single test, every single experimental test that is tried to confirm some effect of that location on your birth, the location of your planet in the sign at the time of your birth has failed, but it's not entirely irrational. So I want to spend a few minutes talking about the role of the myth in the modern world as it relates to these, because the fact that so many people believe, and many people believe and deeply believe in astrology, and you can go find someone who can read you your charts from the time of your birth. This is like a fairly large industry. It was an even bigger industry for most of human history. And I think that it's really important for us to understand why we do this. Why do we need gods, right? Because it seems like gods have been really important to humans all throughout history. And this gentleman, this is Carl Jung. He's he was a psychologist in the 20th century. And I think he's done the best job of anyone of making sense why this happens, right? And what happened in the modern civilization, because, it was Nietzsche who declared that the more we understood the mechanics of what was happening in the world, the more we understood that we're made out of cells, that the stars are made out of atoms, that they proceed in a regular fashion, not because of the whims of some gods, but because of gravitational mechanics, let's say. And Nietzsche thought this would be disastrous, actually. He thought this would usher in something like the end of the world. And this death of, Nietzsche famously declared that God is dead. And what did he mean by that? He meant that we could no longer all get together behind this supernatural vision of things. Not nobody, but certainly people have a really hard time with the idea that there's just a guy up there with a beard who's commanding everything to do what it's supposed to be doing. And so, to some extent, that was good, right? We don't have the same kind of witch hunts that we used to have. We don't have the church persecuting people like it used to. But there's also this terrible chasm that resulted from it. And I think we feel it now more than ever to some extent. And I'm not trying to make an argument for the existence of God here at all. That's not what I'm trying to do. What I'm trying to say is we need to really ask ourselves, what is God in the general sense? Not in some religious context, but what does it mean to people? Why have people been so obsessed with this concept? Anybody? Yeah. Yes, they want stability. That's a huge part of it, right? They want something they can rely on and ask questions to. And that's not unreasonable. And it's not clear that science can provide all of those answers, which is really tragic because we have a hyper-rational society today. And it's often assumed that it's sort of irrational to pay any mind to these mythological stories. But I think that couldn't be farther from the truth, because in some sense, these stories push through the actual mechanics and get into these wider pictures. They actually start to dig into what's inside of us and explain our behaviors back to us. Why else do you think that God has appeared in every single civilization? And anybody? Yeah. That can help me, right? And why can it help? Why can God help you is the question. All powerful, but what is, yeah, exactly. What is, yes. It does, and it means that someone cares about us, right? But God itself represents this by all powerful. It's not just, smiting people willy-nilly, right, in most of these traditions. There's certainly plenty of that as well, especially in the Older Testament, and especially when you get into the Mesoamerican traditions. The gods are actually quite vengeful at times. But the God is also representing, it has the ability to express charity, right? It has this ability to care. And that's a very strange thing if you're a human being, because it's not entirely rational for you to care about other people. I mean that everybody is essentially, if you're entirely rational, you're basically a psychopath, right? If you're just doing things that are the best things for you to do at any given time, well, it's good for me to just take this because I want it, right? But we don't do that. And it's not totally clear why we don't, except for the fact that we all need to get along, and it's going to be a complete mess if everyone starts acting in their own interests at all times. And so, to some extent, the concept of God represents this supreme value. It's sort of like the best way you can possibly behave, right? This isn't trivial that people have stood in place together for thousands of years and thought about what is this archetypical version of the best behavior imaginable, right? And all of the surviving religions, to some extent, they've been abused and so forth, and the churches have taken their own narratives to each of these. But ultimately, whether it's Buddha or the Christ figure, these are role models for how we should be living in the most ideal circumstances. That doesn't mean that they're something that we'll ever be able to pull off. They act as something like a guiding star, right? They're a navigational beacon. That's why they're in the sky. It's not trivial. This is how we orient ourselves, is with this concept of God. And again, I'm not making anything about the existence of God. In fact, I would be very clear with you that the word exists, in physics at least, it has to refer to some sort of material object that has a location. Everything else is just an event. It's a happening, or it's an idea, or something like that. And I would submit to you that God is more of an idea than an object that has a location, right? But that doesn't mean that it's something that can be ignored. It's not something silly, right? It's a really important concept. It's been important to everybody who was your parents' 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 parents. And they all arrived at the same basic notion on every continent, in every civilization. They all came up with very similar ideas about how each one of these gods, or the supreme God, behaved. And they're all quite similar. And that's fascinating, because that means that deep inside of each one of us is a blueprint, actually, for this. We all have the ability to imagine these gods and to be able to orient ourselves towards those behaviors. Honestly, even today, if you ever find yourself in court, right, you're going to swear before God that you're telling the truth. Now, you might say, I don't care, I don't believe in God, it doesn't matter to me. But it matters to the system of which you're a part of. It matters to the civilization. And it's not a matter of existence, right? It's a matter of being aware and giving deference to this idealized behavior. Now, Jung made a really astute observation. In the 20th century, right as rationality sort of displaced church to some extent, and I would say it's displaced it more than ever today. Right as it displaced the church, people began coming down with all sorts of psychological symptoms, right? There's all sorts of chaos that began to appear, actually. And this is predicted by Nietzsche. Now, Nietzsche thought that we would each have to, in order to overcome that, we'd each have to become supermen, right? And we'd have to be able to triumph over our own conditions and come up with our own idea of what God is. And perhaps this is more where you each find yourselves today, with trying to imagine what the best possible version of yourself would be. And what Jung said was that we didn't actually get rid of God, we just pushed them inside. All of these things are just inside of us now. And this turns out to have been a really dangerous thing. If you think about World War II, right? Hitler loved Nietzsche. right? He loved this idea that I can take on the spirit of whatever, and I can design it however I want it, right? I can make God however I want it. But that turns out to be something of a pretty bankrupt idea, right? Because if you can just decide, oh, well, God is as I say it is, and God says that I'm the most important person in the room, then I can take whatever I want, and I can push these people into gas chambers because I decide I'm the Superman, right? God is dead. This is very dangerous, actually, and I want you guys to go out there and think about it, because I'm not trying to encourage you to all run to church tomorrow or something like that. You know, this is not what I'm trying to say, although it would be quite nice if we had a way to get together as a community and actually look at our place in the universe. What I'm trying to say is that by getting rid of gods, by getting rid of the mythology, by sterilizing the astronomy to some extent, we may be doing a bit of a disservice to ourselves. Because you don't want every single person coming up with their own version of God. You really don't. Because that's not going to work out for some people. And that's a very dangerous idea. And it's played out quite catastrophically in the past. You know, instead of going on and digging into the modern astronomy, I think we should put a pin in it for today. And I want you guys to really go off, and I want you to think about these ideas. I would love to hear your interpretations of these myths. And I would love to hear your ideas about the future of the concepts of myths in the world. And let's leave it there. Thank you, guys.